Hello and welcome to my third video in my Introduction to Python Programming series. In the last video we discussed how strings were used and how you could index strings. I'm going to mention in the documentation we're following along with on python.org that there are some further reading sections regarding strings, and we may even mention these further down the line. So you can read these if you wish, and if you have any questions about these, like methods on strings, formatted string literals, formatted string syntaxes. We'll probably talk about this one if we ever do print formatting. And printf style printing, which printf is a more fundamental print function that you see in C a lot, and you can also use it in the command line. So if I say printf, I don't think it works this way. This is a string. It'll print exactly what I told it, but you also need a new line character here, which I had mentioned in the last video. I talked about new line characters. In fact, let's see if we can do that bell character. Yeah, you probably don't hear it, but that's neither here nor there. This was all stuff I covered in the last video, and if you're interested, you can go watch the last video. In this video, we'll be talking about lists. Lists are a kind of a data structure, very fundamental data structure. A list, also known as an array. In other programming languages, they just call them lists here because there's more functionality built in with lists on Python than with arrays. Arrays have like their own information built in with it. And if we get into discussing data types, I'll discuss how lists look in comparison to arrays. Just know that their functionality is very similar. So if I make a variable called myList, and I can assign it equal to whatever I want, as long as it's within these square brackets and comma separated, kind of how you'll see here. 5, 6, 8, 2, 4. And so this is my list of integers, just basic numbers. I can print that with my list or a print statement. You can see that these look very similar. And you can do index notation the same way you can do index notation on strings. If you want the first one, the last one, first to last, you want to print it backwards, we can do that. It's always fun to reverse, so let's start from the last one and go to the first one and see that these are reversed. You'll kind of run into this problem if you continue programming, where someone might ask you to reverse something or make it reversed. So in Python there's a built-in called reverse. So if you type myList dot reverse, it doesn't show anything. It's a capital L. It doesn't show anything because it just performed it. I didn't tell it to print it. So you can see now that they're reversed. It was 5, 6, 8, 2, 4. Now it's 4, 2, 8, 6, 5. We can get it back to normal if we just call reverse again. And then now it's how it's supposed to be. I don't really get the point of doing a slice on nothing. Oh, it says it returns a new list containing requested. So this just makes a copy. If you're trying to make a copy of a list, although I don't know why you would do that. You can just type my list and then my other list equals list, and now my other list is the same. Watch that if I do reverse on my list, and now my list is reversed again. That doesn't affect my other list. Oh, it does. Really? So I guess this makes a reference. So this is why you'll need a shallow copy like this. Let me try. Yeah. So my other list, it points at something that represents what's in my list. So they refer to the same information. That's why you might do this shallow copying. So let's make my list equal, or my other list equal my list, and then we do what they're doing here. Now we can print my other list and my list, and now we'll reverse my list and see if my other list changes. And you can see my list. See now that they refer to different information. Reversing this one doesn't affect the values here. If you do just this just makes a reference, or you can think of it as another variable name that represents the same name. Because you've set them equal, they refer to the same things. Whereas this returns a copy of it and assigns it to this variable. These can more easily be shown in C because I can show you the memory and stuff, but Python manages the memory for you. But that's an instance in why, or a demonstration of why you would use this shallow copying index notation. So again, each of these refers to their own object now, and we can do things like appending or adding. Say this is my list. If I wanted to add another number, I could just do dot append and then pass another value. I'll say there's already a 2. I'll pass 3. And then if I type my list again, you'll see there's now a 3 at the end. And just to further iterate that 3 is not being appended here, they don't refer to the same things. And you can also do some math on these things if you would like. These get into things like lists and loops, and maybe I'll talk about loops in the next video, but we can do math on these values. And you can also add strings. So if you do dot append, you can add a string here. It doesn't have to be a number. And this is one reason why lists in Python aren't the same as arrays in other languages, and that you can do these things. It's more akin to a data structure. So if I print this, you can see string is in there. If you wanted to make a number a string, and you can see that this 3 doesn't have quotes around it, this hello has quotes around it, you can do an append. There's a special function called stir that takes whatever it is and treats it like a string literal. So if I say 45 and I append that to my other list, if I print that, you'll see that this is now a string. Now, the difference between a string 45 and an actual 45 is these are represented as the characters, whereas these are represented as their values. I can't say to the string 45 add 10 and it be 55. it doesn't treat it that way. It says a string is not an int. But this also allows me to introduce another function called int. Int takes whatever is the input and treats it like its value. So I can do this. And if you are trying to read something from, like if I were to copy this and rip it out of this web page in a program, it would treat this as a character string. And then I can do some parsing of this to say, well, anything that's a character that is represented as a numeral, I want you to treat that as an actual integer and not just this string of whatever it is. Oh, and here's it talking about the append. We talked about slicing and also length. Length. Like I said in the last video, that length just returns the amount of characters in something. You can actually think of a string, this string, as being equal to an array of characters, H, let me move my mouse, E, L, got L. I've never had to type this series of characters before. Oh. Okay. So you can think of hello, the string, as being an array of individual letters like this. And so it's not that far of a leap to say, well, if I want to change these, well, if I want to index these, and I believe no, I haven't talked about, well, I have talked about string indexing. So if I had an array of numbers, you can think of it as the same. In fact, this gives me a chance to demonstrate something else. We can do my list plus equals my other list. I think I mentioned you could concatenate strings like this, but you can also concatenate arrays, because again, strings are kind of like lists of characters, as what a string is. So if I do this, now my list has everything that my other list had appended to the end. So my other list had the hello in it and the 45, where my list had all these. So you can see that they don't duplicate these. And you can see in here as well. You can also make a new array or list. I keep calling them arrays, and I might do that on accident. I'll call this one new list equals, I'll just say A, B, C. Okay. This new list has A, B, C in it. If we wanted to make another list of both these lists, and I'll reassign this to my other list. My other list equals new list and my list. So I can do it like this. Now my list will have these two lists inside. So this is like a list of lists, which you can do, and this is how you can think of, since this is a word or was a string, multiple strings can be used to make like a paragraph or something. You could think of it that way. Mathematically, this is more like a matrix, but if we ever get to that, we'll discuss multi-dimensional arrays and what they're good for. That seems to be the end of the string, or of the lists. This introduces some things like loops and how you would use loops to do like math or some stuff. And we'll talk about those in the next video. Or let me see what sections are coming up, actually. Yeah, so we get into control flow. This is where a lot of the programmatic stuff that we will need to do the project for this series. We'll need a lot of these things. So join me in the next video for those.